Hello. Thank you for joining me today to learn more about promoting academically productive talk in the science classroom. I am Stephanie Harmon, a regional teacher partner with PIMSR, the Partnership Institute for Math and Science Education Reform. This is the first video in a three-part series, Academically Productive Talk in the Science Classroom. As you participate in this workshop, this video can be used individually, with a grade level group, or PLC. You will want to have access to the following materials. You will want electronic access to the resources that accompany this video and either an electronic document or use paper and pen to capture your notes. Let's look at the focus questions for today. Why is effective talk a critical element for student learning in the science classroom? How can we engage students in academically productive talk? What strategies can we use to engage students in scientific conversation with other students? Our goals for this session are: understand why effective talk is so important in learning science, and learn how to engage students in academically productive talk. Pause the video to consider these questions. How do you engage students in productive science talk? Why is productive science talk important? Jot down your ideas on your note taker. Restart the video when you are ready to continue. Examine your notes. If working with a group or PLC, take a moment to share your ideas. What do you notice? As you move through this video, add new ideas to this list. So let's look closer at our first focus question. Why is effective talk a critical element for student learning in the science classroom? Use your note taker to capture your ideas. Effective science teaching and learning requires the three key elements listed here. Think about why each of these elements support student learning and how scientists engage with these elements in their work. Today, we will focus on the role of discourse and how to begin to build a classroom culture where all students have a way to enter a scientific conversation. We will return to the three elements in future sessions in this module. In John Hattie's research on the effect of different learning innovations, effective classroom discussion has an effect size of 0.82. What does this mean? So an effect size of 0.40 is considered a hinge point. Any innovation with an effect size above 0.40 has an impact on student learning, which leads to more than 1 year's growth in 1 year's time. An effect size of 0.82 means that a student engaged in meaningful classroom discussion has the potential for 2 years' growth in 1 year's time. So engaging students in science talk has a tremendous impact on student learning. Listed here are reasons for why talk needs to be considered a key way to make thinking visible. This talk allows the teacher to formatively assess in the moment as they listen to student ideas. The Turk Talk Science Primer written by Sarah Michaels and Kathy O'Connor, also emphasizes how science teachers can support academically productive talk as a tool for promoting powerful student learning. Individually, take a moment to reflect on what you just heard. Based on what was shared or other research you have done, what are two key reasons for why talk is so important? How does this compare to the ideas you jotted down earlier? If you are working as a group or PLC, take turns sharing a reason and develop a collective bulleted list based on your experience and research for why talk is so important. So now let's look at our second focus question. How can we engage students in academically productive talk? Pause the video, get your note taker, and open this document. Take a moment to review it. What is the title of this tool? What do you notice about how it is organized? What is in each column? How can a tool like this be useful in supporting talk in the classroom? The Communicating in Scientific Ways chart, also known as the CSW chart, was developed by BSCS Science Learning. It is part of the Open SciEd Teacher Handbook. The intention of the chart is to promote student communication with one another so that it becomes a natural part of classroom interaction. The sentence stems provide students a mechanism for sharing their initial ideas, revising or clarifying those ideas, challenging those ideas, and support students in assembling their ideas. So the CSW chart becomes our tool for engaging students in scientific discourse. So what strategies can we use to engage students in scientific conversation with other students? Consider these stems. How come? I wonder how. I wonder why. How do they know that? We will examine a brief video clip. As you view the video, use the stems to craft statements. If you are viewing with others, be ready to share your statements. Examine your statements. If working with others, take a moment to share with the group. Some possible statements may be, I wonder why the pie pans fly off the top of the Van der Graaf. I wonder why only one pie pan flies off at a time. How come this happens? These stems can be used as students engage with a variety of texts, such as video clips, images, tables, graphs, or reading passages, doing an investigation, or watching a teacher-led demonstration. Take a moment to consider how these stems can be used in your classroom and for what purpose. I have used these stems in a similar fashion with high school students. Students use the stems to write about their ideas, then use the notes to enter into conversation. Students can share their thinking with a talk partner or a small group. As they talk about their ideas, they look for similarities as well as different perspectives. In the pie pan demo example, we use the stems first to write, then to talk. In a similar way, we will use stems to write about this photo. Take a moment to look at this photo of a sunset. Create a T-chart like the one you see on the right of the screen. Use the stems I see and I notice to complete the notice side of the chart while you examine the sunset image. Now let's look at the right side of the chart. Label it Wonder. Let's use a couple of the stems from the pie pan demo example. I wonder how and I wonder why. Add questions about what you noticed in the sunset image. You may want to pause the video for a moment while you do this. So what did you notice? What did you wonder? If working with others, take a moment to share with a group. What did you take away from doing this task? Why is it important for students to talk about their noticings and wonderings? In the classroom, students can turn to a talk partner or come together in small groups to talk about their charts. This conversation can lead to students collaborating on creating a larger notice and wonder chart, which can be used in whole class discussions. Science students benefit from sharing ideas with peers, interpretive accounts of data, and working together to discern which accounts are most persuasive. This is why student talk is so critical. Consider how scientists work. Scientists do not work in isolation. Rather, they collaborate in teams or groups to communicate their findings, ideas, and data. As students collaborate in a similar way, their learning increases. Stop the video to consider this statement. This statement is also from Ready, Set, Science. Scientific communication must be explicitly taught. It does not develop simply from doing science activities. Scientific communication is more than using scientific terminology. It is discourse that values the use of evidence, coherent reasoning, and consistency of explanation with data. What are the implications for instruction? Take a moment to jot down your thoughts and/or share with your group. Let's take another look at the CSW chart and consider its relationship to the science and engineering practices. Students should be engaged in using practices in every lesson. Which of these do you think are currently strengths in your classroom? Which need more development? How can student talk build student capacity in the practices? Take a moment to reflect on each of these questions. Share with others if working with a group. As you consider the relationship between student talk and the science and engineering practices, know that there is a video series focused on the science and engineering practices that can be used to deepen your own understanding or develop a shared understanding within your group. So let's compare the science and engineering practices and the CSW chart. How does each element in the How We Figure Things Out column compare to how students use the science and engineering practices to figure out a design solution or phenomena? Stop the video. Work with a colleague to answer this question. When you are ready to continue, open the CSW and SEP relationship chart. How does your thinking compare to this chart? Take a moment to discuss with your group. Let's consider the instructional implications of the CSW chart. How would you help students start a conversation about this data set? Which CSW strategy would be most appropriate? Why did you select this strategy? One possible choice is CSW number 3, organized data and observations. This supports the science and engineering practice of analyzing and interpreting data. The STEMs prompt the students to consider if there is a pattern in the data, as well as possible options for what to do with the data, such as make a chart or graph. Other possible choices are CSW number 2, observe, or CSW number 4, think of an idea, claim, prediction, or model to explain your data and observations. The STEM set we use is dependent on the purpose of the conversation. As you begin using the CSW chart and the STEMs with students, consider how to share the chart based on your grade level. Looking at the whole chart might be overwhelming for any level of student. Younger students might require you to cut apart the STEMs and give them only the numbers they need to focus on for the aspect of the lesson. Another consideration is how using these sentence stems will impact the student's overall learning. Some students aren't sure how to begin a scientific conversation or lack the confidence for doing so. There is a need to support all students in how to engage in productive scientific talk. These stems can be used for both talking about and writing about science. Regular use will also impact student work in other subjects. Teachers in self-contained K-8 classrooms have shared how using these stems in science positively impacts the learning in English language arts and social studies. From my own regular use of stems with high school students, I have found over time that students use the stems without being prompted to do so. The stems are the conversation starters that lead to rich classroom discussion. Evidence of STEM use is also seen in student writing as the quality of their explanations and scientific arguments has increased. Consider our focus questions for today. What are you taking away from the session? Take a moment to think about this. Jot down your thoughts. If working with a group, share your ideas. Let's revisit our session goals. How will this session build your capacity in each of these goals? There are 2 other videos in this series. In video 2, we will work together to explore strategies for developing an effective classroom culture where all students have a voice and can engage in scientific conversation. In video 3, what do the strategies from the first 2 videos look like in action? We will take a virtual peek into some classrooms to see the strategies in action and think about how this can be used to help you plan for implementation. I hope you will join me for both of these.